All right, y'all. So here's the deal. We're gonna get into randomness now, and we're gonna still continue working on the apple tree code. But I wanted to at least take a pause and let some of the other stuff sink in before you got into the next stuff. So when we add randomness, basically what we're doing is we're adding a little bit of variability, and trying to make this a little bit more fun, make it a little bit more unpredictable. So down here, for our next bit of code, we're going to use random values, and we're going to use the variable that we set up as a chance to change directions, right? So this is all going to be part of this big if else if sort of scenario, right? So as we're checking things, every update of the screen, if we're at the left or the leftmost edge, then we're going to flip the variable from negative to positive. If we're at the rightmost edge, we're going to flip it from positive to negative. Now, if neither of those things were true, then we can add in a third situation to our logic, and so that's going to be this else if random value chance to change directions. All right, and so how this is going to work is oh man, I want that to just be away. It keeps coming back, and I don't want it to come back. All right, so here we are. So when I'm adding this else if, notice that my else if is going to be positioned after this curly brace. People call these mustaches. I think that's fun, but I still haven't gotten into the habit of saying that. So we're going to say a random dot value and is less than chance to change directions. All right. Then we're going to put, oh, sure, I'll call it a mustache. Fine. We're going to call it a mustache. And let me just set up the editor so you can see what's going on. So I have this chances change directions. I'm going to add in my, I'm going to hit enter a couple of times and just kind of clean up the code view so that things are working. And so I'm gonna see if there's a random value that we can bring in here. Now the chance to change directions. Let's take a look at what that value is thus far. The chance to change directions is 0.1 floating point, right? So what that means is that this is going to be 0.1. Our chance to change directions is a 10% chance. So a random value as drawn by the computer or as picked by the computer is going to be a value between 0 and 1. All right, so random values are between 0 and 1, right? And then if we want to do something with those random values, we have to play by that logic. But like we could, if we wanted to have a program that picked a number between 0 and 10, let's say, we could have the random values be multiplied by 10 so that we have, instead of 0 and 1, if we multiply it by 10, we would have a 10 as the utmost value. Right. So, so we can add multipliers and things like that in there. We'll leave that aside for now. Let's take a look at what we're actually doing. We're going to change the direction of the motion by updating the speed value to a negative value. So speed is going to be multiply equals, so times equal -1. All right. And what this does, it allows us to use pause negative to change directions. Right. So nothing terribly special here. This is another operator that you'll be able to get acquainted with. But let's take a look at what happens when I hit play. And I want to make sure that when I hit play, my apple tree is selected so that I can see the variables changing. If you're not seeing this stuff over here, then you want to make sure that over here in the inspector you have the apple tree selected. All right. So what you see happening on the screen is that this tree is looking a little bit jittery. The randomness is not quite ideal, but and so that gives us something that we can play with. What we could do is change some of the values in here to make it a little bit less jittery. We could also change the chance down to 0.01, and that's going to basically be, one every 100th update. There's a chance that it would change directions. So we can really kind of fine tune those variables as we see fit. I think 0.02 is going to be the sweet spot, but we'll see what happens. I'm kind of going by the book just to make sure that we're sticking with Gibbs and Bond's updates. And it says right here in the inspector, change the value chance to change directions to 0.02, and it should feel a lot better. And he was right, it certainly did. 0.02, and so I'm going to leave that as the value there. And when I hit play, it's going to certainly be a lot smoother and a lot easier to contend with. Now, what's great about this is that we can have those values in there by default, but when we're working with the game, what we set in this script over here, this space for the variables, those values are going to stick. All right. Right. So now, he continues the discussion of time-based games. Chance to change directions is not time-based. Every frame, a 2% chance exists that the apple tree will change directions. On a very fast computer, that could happen much quicker than the screen could even update. So what we want to do is, instead of having an update, a void update, we're going to create a new section of code called void fixed update, which allows us to make our code randomly time-based. Now, I told you that I had asked you to download BB Edit if you're on the Macs. And what this allows you to do is, I'm going to create a little new document here. If I'm cutting and pasting any code from in here, I can copy this code, but since it's coming from a web browser, it might have a whole bunch of garbage in it. And so pasting it into here allows me to clear out some of that garbage. If I paste it into a text editor, that's the only reason why I asked you to download that text editor. What this has are some text commands that allow you to clean this up a little bit. So I'm going to go in here and do zap gremlins, and I'm just going to delete all the weird code that might show up in there, and I'm going to copy this out of here again and then paste it into my apple tree code here. So that's going to go under fixed update. So we're going to trace here. So this void, right, is going to be contained in this space. So I'm going to go down to after 56, whichever line I was on. I'm going to paste in that fixed update. And you'll see that once I paste it in, things are looking okay. I'm going to get rid of that little b. And then what I want to do also is get rid of this code here under this else if. Right. So I'm just going to leave. I made a couple of changes here. I'm going to leave this on the screen for just a moment so that you can see where to put fixed update. I still recommend typing things in, but in the interest of time and efficiency, I wanted to clean this up. And so fixed update is going to lock this to be time-based and not dependent on frame rates and computer processing speed and that sort of stuff. So with that, when I go back over here and hit play, we hope that things are going to run. And our tree seems to be moving okay. We have our options showing here as the chance. And if I wanted to be more granular about this, I could make it a chance of 0.15. And that seems to make me happier. So I'm gonna hit stop there. I'm gonna save the scene, and we'll move on to the next little bit. All right. So so hey, look at us. We're coding. It's fun. All right. Now what we're gonna do is set up the scenario to drop some apples. All right. So check this out. We're going to build a relationship between the apple prefab and the apple over here. And you see this little guy over here? I'll zoom in here. See this little guy over here? This is a little pick whip. Pick whip allows you to basically drag and drop over to another aspect of this interface and pick out a little prefab to use. So I'm going to grab this and oh goodness, I'm thinking about man, my brain was on After Effects with that pick whip. You know what a pick whip is if you've used After Effects. But what I'm going to do is go over to Assets, and I pick out my apple, and that becomes my prefab over here. So what you should see is the apple prefab is now listed in the inspector. Right? We haven't changed anything about the scene, but I'm going to save it anyway so that we have all the current information in there. And then we're going to go back over to the book just to make sure we're doing things the right way. So it said select apple tree in the hierarchy, look at the apple tree script, grab the apple prefab. It goes from none to the, then we pick the apple from the assets tab of the window that appears. And you could also drag the apple game object prefab over to the prefab value in the inspector pane. So I could have done this if I wanted to. Get back out of there. What I could have done is just take this apple and drag it all the way over here, and then drop it in to place. So that's probably a little bit easier. I was thinking in After Effects mode with the pick whips and that sort of thing, and it's hard to keep track of all this stuff, but we do our best, right? So now we're in the apple tree, and a couple of things are going to happen here. So we're going to create a new void here called drop apple, right? And we're going to do this from the starting point here. So we're going to go into start, and this is going to work just like I described the other day with functions, right? So we're going to invoke a function called drop apple, and we're going to invoke that every 2 seconds, right? So 2f. So we're going to go invoke, and we're going to put in quotes drop apple, and we're going to say 2f, right? All right, and so now once we have that in place, this is what's going to allow us to drop the apples. Now down below that, we're going to put in a new void, and we're going to call this drop apple. Okay. And then we're going to put in our curly braces. I'm going to hit enter a few times. And just to remain consistent with how he has things in the text, I'm going to bring that up to this line. Although Visual Studio really wants it to be on other lines, so, so I'm thinking about changing my my tune here. But what we're going to do is we're going to say game object, and we're going to say apple equals instantiate. This is fun. Instantiate, and then we're going to say game object, and that game object is going to be the apple prefab. Okay. And then we're going to say apple.transform.position equal transform.position. So we're going to capture the current transform position of the apple, right? And then we're going to invoke drop apple. This is going to be deceptively simple, but it's really complex. So we're going to do invoke drop apple, and we're going to do seconds between apple drops. Okay. So this is our code, right? We have on the start of the game, we're going to say invoke drop apple every 2 seconds, right? And then when we drop apple, so this calls drop apple. And then what we're going to do is we're going to create a game object called apple, and it's going to be an instance of the game object apple prefab. All right, so let me break this down for you. We'll go back into Unity. We'll talk about it in real plain English. All right. So we have the apple prefab, right? It's this guy, right? We have this apple that we created. Now this is the prefab, right? In the apple tree script where we are, right? When I click on apple tree over here in the hierarchy, we have the apple tree script, and apple prefab is a variable that we have linked to this apple. If we link it to something else, it's going to drop, drop baskets on us. But instead of dropping baskets on us, it's going to drop apples on us because that's the one we picked, right? So we're going to say, give us one instance of an apple. Cool, right? And then once we do that, we transform the position of the apple based on gravity. It's going to be dropping, right? So we're going to find out where it is, and then we're going to invoke drop apple again from within this, from within here. So we're going to continue to keep dropping this apple as we go along. All right. So let's get a sense of what's happening here. There's a long explanation, but we're going to wait 2 seconds, drop an apple. It's going to be one instance of an apple. And next time, it's going to be the second instance of an apple. The next time, it's going to be a third instance, and so on and so forth, right? Now, the position of the new apple is going to be set to the position of the apple tree, right? So let's go back in here and take a look at what's going on. So the apple transform position, which is this game object here. So this game object apple we can use here. So just to see that those two are related together. So transform position is going to be the transform position of the apple tree, this main big object. All right. So then, after we have our timing down and we're able to drop those things, invoke is called again. It's gonna drop the apple again each half a second or each 1 second afterwards. And there's a reason for this. Let me go back to this code here for just a second. All right. Here, this is the start. We use this exactly once and once only. So if we're going to start the dropping apple sequence, we're going to invoke drop apple the very first time. And then down here, under drop apple, we're going to keep invoking drop apple all the way through our program. At a set interval every 1 second. So now drop apple is just going to hang out and do its thing, right? So we are not changing anything in update, and so I'm going to go back over to here and cross my fingers and hope something happens. Whoa! Oh no! Oh dear! Oh dear! Something has gone terribly wrong. Ah! Oh, let's see that again. You want to watch that again? Okay, so things are oh no! I just dropped an apple, and now, it's things have gone terribly wrong. Oh Lord! Oh, so what has happened? All right. I can't get over this. It's too funny. All right, so I'm gonna go back to it's all gonna be happening in the script. So I'm gonna go back to the apple tree script, and let's hope let's hope we can solve this, right? So here we go. Did you expect the apples and the apple tree to go flying off? No, we did not expect that. But it did it. It did it. And you thought you did something wrong, but he tricked you. He tricked you. That's not good. So what we want to do is change something. The first thing you do if something like this is happening is set the apple tree's rigid body to be kinematic, which means that we can move it via code, but it won't react to collisions with other objects. Okay? So I'm going to go back into apple tree. And I'll be honest with you. I encountered this in another scenario and I forgot to check this, and it is always as ridiculous as it seems. It's too much fun to see it happening. But like, I'm gonna hit play again now, and so is kinematic. I wait 2 seconds and now there it goes. Whoa. um it's pretty violent, really. That second one that it's shooting out there is very, very violent. Okay. But this is a little bit closer. So now what we see are these apples that are being created and cloning, and they're just going to keep going and going and going and going. Check this out. Like, so if I zoom out of my screen, let's see. I don't know if I can do this while I'm playing. All right, I'm going to zoom way, way out of here. All right. I'm going to zoom way, way out. All right, I'm going to hit play again. All right, and so watch what happens. See our little apples? They just keep existing. They just exist all the way down until they're always going to be there. All right, so that's going to be something we're going to need to solve on the way through here as well. So I've got this drop apple. I've got the seconds between drops, and things are kind of working. So the apples are still colliding with the apple tree, and they're going a little bit faster, and I need to do something like this. So to fix this, you need to put them in a physics layer that doesn't collide with the apple tree. A physics layer is a group of objects that can either collide with or ignore each other. So if the apple tree and apple game objects are placed in two different physics layers, and those physics layers are set to ignore each other, then the apple tree and apples will cease colliding with each other. And that's why we need layers. So what we're going to do is we're going to create a user layer for each one of our objects. So we're going to have user layer 8, 9, and 10 that are going to be apple tree, apple, and basket. All right. So let's do that. I'm going to go into layer. I'm going to add in layer, and I have user layer 8 is being used by post-processing. So I'm not going to change that because I don't know what that's all about. But I'm going to say apple tree. Right. My layer 10 is going to be apple. Oops. And the third one's going to be basket. So it's wild when things go nuts. It's a lot of fun. All right. Anyway. Oh goodness. I can zoom all the way back in here too, so we can see a little bit of what's happening with our game here too. All right. So I have my layers. Right. I've created those layers. Now what happens? I go into the apple tree in the hierarchy, right? And I do choose layer, and I'm going to put the apple tree on its own apple tree layer. And it's going to say, do you want to set the layer to apple tree for all child objects as well? And I'm going to say yes. I'm going to say yes to that. Change all the children as well. So they're all going to be on the apple tree layer. And then okay. I was starting to do this a little bit backwards. We are going to set this layer first, but I'm going to I'm going to put the layer back to default just for a moment on the apple tree. So if I was going to be going back and editing, I would say just ignore the previous minute. All right, so here we go. Once we have layers, we're going to go in and you're going to go into the physics manager. So we're going to go to edit, then project settings, and then the physics manager, which is under this like obscure looking menu here, but there it is. So under physics, and this is like if we wanted to change gravity, this is where we would do it by default. Bouncing and all sorts of different things. We would want to set those things up. Well, we've got this collision matrix here that allows us to do some things. And I'm going to zoom into this after I change the settings that I need to change. But basically, we're going to make sure that the apple is not colliding with itself nor with the apple tree. Okay, so you can see this as an example in the book, but I want to show it to you in real time here that we want to make sure that the apple is not colliding with the apple tree or itself, right? So fantastic. We can close that out. There's no real save there or anything to be aware of, but I'm going to go back in and double check that those things are set, and they are indeed set. So there's no save. The things will automatically update for you. All right. So now, once I have set that up, then I'm going to take the apple prefab, and I'm going to put the apple prefab on the apple layer. And I'm going to take the apple tree prefab, and I'm going to put the apple tree on the apple tree layer. I'm going to change the children. And while we're at it, I might as well put the basket on the basket layer. And so those are all now on their own layers. If I hit play, let's see what happens. Still kind of shooting them out there. So I may want to double check this. All right. So you want the apple to collide with the basket, not to collide with either the apple tree or the apples. So we change the matrix and then click the apple in the project pane, select apple from the layer pop-up, basket, apple tree to apple tree. And it says, we should see this, and we did want to change children. And what I wanted to do is see the apples dropping properly from the tree. So I must be missing something. And so in times like these, I hit pause, I figure it out, and I'll come back to you with an answer. And I found the problem. So I had an apple is on the apple layer. I have my apple tree. I'm going to put the prefab on the apple tree, but the apple tree over here in the scene also needs to be on that layer. And then I have the basket, and the basket should be on the basket layer. So the reason why it didn't work for me just then is that I did not, and I should have, but I did not put the apple tree layer, or the apple tree on the apple tree layer. So when I do that, I select apple tree and I do yes, change children, and then up here you should have this layer as apple tree. All right. So and be mindful. I'm going straight through because it's a recording. You can always rewind. So so let's now see if things are working. And then gentle drop. Oh, that's nice. Drop, 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 drop. Okay, so now we're going to have some nice apple dropping. Wonderful. All right. So now, then we're going to stop the apples. There will be a lot of apples in the hierarchy. I described that to you earlier. And we're going to destroy the apples whenever they go too far. And so we're going to use this little bit of code here. And I'll just move my code over a little bit and scoot this in. And then right down at the bottom, before we get out of the update, we're going to do... Oh, no. It's not on the apple tree because it's not on the apple tree. All right, so I'm going to close this out. So on the apple C# script... Glad I caught myself. All right, so in this apple C# script, we don't have anything in that one yet. All right, we haven't edited this one. Yeah. All right, so let's go back to this. All right, so here, what we want is a little value to hold our data. So we're going to do a public static float, and we're going to call this bottom y equals negative 20f. So 20, a position of negative 20 should be good enough for that thing to go away. All right. And then we don't need void start in here, but I'll leave it. And then I'll put in void update if transform dot position dot y is less than bottom. Okay, bottom y. And then we put our squigglies in there, and then we're going to say destroy. And this is a great. This is great. This dot game object. All right. The keyword this is really part and parcel of object-oriented programming. This refers to the current object, whatever the current object is. Now, we have lots of apples that are going to be floating around on the screen. We don't want to have to keep track of that by number. We're not counting like apple 1, apple 2, apple 3, apple 4. We don't want to do that. We don't have to count that stuff. So we're just relying on the computer to keep track of which apple is responding to this script. And so if we want to destroy something, we'll destroy this game object. All right, how this program or how this little script works is we have bottom y, it's going to be negative 20, and we're going to check against negative 20. If negative 20 is greater than transform position y, or if transform position y is less than bottom y, right? So if transform position y is negative 21, bottom is negative 20, we're going to destroy the game object. All right. So now, when I go back in to my code, and I just saved the script, and so we'll watch the apple dropping, and you'll see some of these starting to list over here, and then a few of them will go away. All right. So just wait. Seems like a lot of them. All right. Still feel like that one's not quite working. So, maybe I should attach the script. That would help. All right. So I'm going to take this apple script. I'm just going to attach it to the apple. All right. So now we have the apple script attached to the apple. So, sorry, folks. That's one thing. If you want something to work, you have to attach it to an object, and I think that's important for you to see. It's important for you to see my mistakes. We all make mistakes, right? So I took this apple script and I just dragged it to the apple, and it applied there. All right. So now, when I hit play, it's going to drop. 1, 2, 3. There we go. Now, you're going to see them disappear after they have gone off screen. We can see them disappearing up here, but they will have dropped to the bottom of the screen by the time they disappear for us on our viewport. All right, so that seems to be working okay. We'll go back to the code just to verify what's happening. You want to make sure that apple is attached to the apple game object in the assets, because it's a prefab. And then we have this little script running against it. All right. So this is the little step that I missed. You must attach the apple script to the apple game object prefab. All right. So then apples are done, and then we just have to do baskets. All right. So I'm going to close out the scripts that I've already worked with, and we're going to instantiate the baskets. Now, here's what's fun. Check out the baskets. We made one line for a basket, but in our C# script, we're going to actually make 3 of those lines appear, so that we can keep track dynamically of how many how many boxes or how many baskets we actually have on the screen. That's going to be fun. All right. So let's start here. Um, So one of the things about this tutorial that I'm not crazy about is that everything's named Apple, Apple, Apple. That can be kind of confusing. But what we're going to do is back over in Unity, we're going to take this Apple picker script. This is sort of the main game script, right? And we're going to attach it to the main camera for the game. So Apple picker, we're going to have this be the main game script, and it's going to be attached to the main camera. All right. So we save that. If I click on the main camera, you'll see Apple picker as a script here. All right. The scripts that we've worked on thus far were Apple tree and Apple, and we haven't worked on. We're not going to work on basket yet. We're going to take a look at the main camera. We've got the Apple picker script over here, and I'm going to double click on Apple picker, and it's going to give us our Apple picker script. There we go. And we're going to use the generics and all that stuff. And in this space above void start, we're going to type in some code here. So I'm going to go public game object basket prefab. We're going to go public int num baskets equals 3. We're going to go public floats basket bottom y equals negative 14f. And then we're going to go public floats basket spacing y equals 2f. Okay. So those are some values for us to work with. I'm going to put those in line so we can see them nicely whenever we're looking for them. And so we have a basket prefab. That's the game object. The number of baskets, we're going to have 3 of those. We're going to have the bottom y. It's going to be at negative 14f. And then the spacing y is going to be 2f. So it's going to be the space between these boxes. And as I mentioned, we're going to have 3 boxes that show up in this space. Now, the logic here is covered in one of the previous chapters, and obviously we haven't had you go into those chapters yet. So you're going to see this happening and working for the first time, and then you'll go back to those chapters and kind of correlate that stuff. I'm going out of order intentionally. I want you to see this working in action. I want you to go through the process of typing code. I want you to go through the first tutorial not knowing what you're doing, right? Like, that's going to be helpful. Trust me. Trust the process. Here we go. Okay, so for int I equals 0, I is less than num baskets I plus plus, right? We're going to do game object t basket go game object equals instantiate game object. I'm off the screen here. Basket prefab. Okay. Double checking. So instantiate game object basket prefab. All right. It's t basket go game object. All right, and then we're going to do vector 3, which is going to be a popular thing for you. We're going to do position. It's going to be vector 3, 0. That's going to give us a 0 value. Kind of cool that we have that available. Position.y is going to be equal to basket bottom y, and this is where we're going to assemble our variables. So we're going to pull in that negative 14f there, plus, and then basket spacing y times I. So this is tricky math, but I'll explain it. Basket spacing y times I. And then we're going to go t basket go dot transform dot position equals plus. Okay. All right. So this same pattern occurs in the other scripts. We use POS as a vector 3. That's our position variable, right? This time we're using the y, right? And so what we're going to do here is we're going to create 3 baskets. Num baskets is going to be 3. So let's substitute 3 here for a second. We're going to say, starting at 0 and counting up to almost 3, not all the way to 3. We're going to go 0, 1, 2. So we're going to count from 0 to start off, and checking against I is less than 3. And then I++ means add 1 to I after we're done doing whatever's in this little section called a for loop. Okay, so a for loop is basically going to allow us to go through this once, increment the number I to 1, go through it a second time, increment the I to 2, go through it a third time, increment the I to 3. After we've checked it the third time, 3 is going to be less than 3. Right, so that's going to check for true and false. So I is less than 3. So as long as it's 0, 1, or 2, then it's going to do this thing. So we go through it 3 times. This is a really, really fancy way of telling the computer to count things, right? And when we count things in computer land, we start at 0. Right? So 0, 1, 2. That's going to be 3 times. 0, 1, 2. 3 times. 0, 1, 2, 3. So we're going to create 3 baskets here. So check out whether, let's check out whether this works. All right. I'm going to hit play. Nothing's on the screen. I hit play. It's still nothing on the screen. Okay. So and that's where it's going to tell us an error here. It says unassigned reference exception. The variable basket prefab of apple picker has not been assigned. You probably need to assign the basket prefab variable of the apple picker script in the inspector. Thank you. All right. So check this out. In main camera, this is where we added our apple picker script. Right? We have this basket prefab, and it's not listed as anything. So what we want to do is take this basket prefab, and we pop it in there, and drop it in there, and now that basket prefab is now basket. Remember, you could also pick from the list. But once I have that object, once I hit play, my error goes away, and now I've got these little 3 equal signs down here. It's looking like the Human Rights Project over here, but it's not. It is just these are just 3 baskets that we have in place. And look what we're doing. We're catching some of the apples, and some of them are falling off to the side. So now we have some core functionality here. So here we are. We got the baskets, and now we want to be able to move the baskets with the mouse. Yay! This is fun. Just keep telling yourself that. Just keep saying it's fun. So, and I honestly, I think this is a lot of fun, and you probably hate it right now, and that's totally okay. Hate it now, and you'll love it later. You will love it later. All right, so I'm going to go into main camera. We have the script attached. We have the basket script attached over here. And I'm going to go back to my code, and it says moving the baskets with the mouse. So attach the basket script to the basket prefab in the project pane. First step. All right, so basket, we bring that over here, and we make that attached to the basket. So basically all I did was take this, and I dragged it over to here, and allowed that basket to be put into place. On the basket prefab, once we look at that script, we can see that it is attached over there. Okay. It's helpful if you're not using any of these values to just scroll them down so that you can get rid of them. We're going to have some variables and things like that that are going to show up in here. All right. So check this out. I said check this out a lot. So check this out. We made this script on the Apple Picker. This is on the game camera, right? So we created the baskets here. We're not doing anything else with them for now in the Apple Picker space. So I'm going to make sure that that's all saved. And now notice that down here I got this error that says I got this inconsistent line endings in the Apple Picker CS script. And that means that there's something weird in here. I don't think I copied and pasted anything in here, but I can't be certain. I don't think I did. I didn't copy or paste anything. It's just saying that there's inconsistent line endings. So what I do in that case, I hit copy, and I go into my BB edit, and I hit paste, and I go in, and I do my zap gremlins, and I zap those gremlins. I think I maybe have to select everything and do zap gremlins. Zap that, and then I copy that back over, and I paste it in, and it doesn't look that much different, but I'm gonna trust that this computer knows what it's doing. And so I hit play, and now it's better. All right. So that's honestly, I know that was a weird little diversion, but you'll get those little errors down here every once in a while. It says like, you know what, there's something that's going to break. And you want to pay attention to the things that are happening down on the console as you're working. Okay. That was fun. That was not a fun diversion. That was not fun. But this next part definitely will be. So we're looking at the basket. We're looking at the basket script. I'm going to double click on the basket script. That takes us over into our code, and I'm going to go back over to moving the baskets with the mouse. And over here, we're going to do some things with this code. Now, I want to type this in because I think it's really helpful to see it being typed as we go. No variables. We don't need start. I'll leave start in there for now. I just want you to be used to that. All right. And so we're going to say vector3, mouse pause 2D. Okay. It's going to be input dot mouse position. Okay. We're going to use a vector3 to hold on to the mouse position. All right. So get the current screen position of the mouse from input. We're finding out where the mouse is. All right. Then we're going to say mouse pause 2D dot Z equals negative camera dot main dot transform dot position dot Z. Okay. That's a long way of saying that we are going to use 3D space to move this camera. Okay. Then here, we're going to convert the point from 2D screen space into 3D game world space. So then we're going to do vector3, mouse pause 3D equals camera dot main dot screen to world point. And then we're going to go mouse pause 2D. Okay. And then the last 3 lines are going to be vector 3 pause equals this dot transform dot position. And then pause dot x equals mouse pause 3D dot x. And then this dot transform position equals Okay. So all of that stuff is happening in the void update for the baskets. Okay. So each basket is going to be tracking the mouse position at the same time. We're going to use the mouse to control the baskets. What this is doing, it's grabbing the current mouse position in 2D, right? Because the mouse, it's a flat representation. It's X and Y. So this moves on the X or the Y, right? Now, we're adding in a Z value so that we can allow the mouse to be translated into 3D space, okay? So now for doing so, we basically are taking the camera position and mapping that to the Z position of the mouse. He explains why we use a negative in there. I'm not going to belabor that right now. Then camera main screen to world point mouse pause 2D. That's going to give us a vector 3 that has the values of the camera. We're going to map the screen to the world point and mouse pause 2D. We've added the Z value to that, and so that's going to be a 3D representation of things. All of this is to say the first 3 lines map the 2D mouse position to 3D and attach it to the camera. Then vector position, this transform position. Anywhere our mouse goes, that's where our baskets are going to go. Okay, so mouse position 3D X is the position X, and then we transform the position. So this is happening on once per frame per update. And let's just see. You know, it's always fun to try it out and see what happens when I hit play. Right. So down here, when my mouse position is moving, then my yeah, that's fun. Then my apples are moving, right? So try it out, you know, in between things, and you can actually kind of see where you might use this in different ways too. You might need to catch something if you're, you know, if you're trying to do like an interesting maze game or something like that where there's gravity involved and you have to kind of like move the 3D maze. You could do something fun with that. Anyway, all of these things could potentially be little prototypes for different aspects of games, and you can just kind of recombine these to your heart's content. So so that's fun. Now we have the mouse reacting to things. So pat yourself on the back. You've gotten really, really far. If you made it this far in the videos, you've gotten really, really far. And I'm excited for where you go next, right? So the apples aren't really being caught; they're just kind of colliding. Now what we need to do is detect for the collision. So I'm going to stop this recording here because we have our game set up, and now we're at the point where we're going to catch apples, and we'll make this into the next video.